Yeah, in today's lesson we're going to look at the BDA theory part, specifically to the introduction to data analysis. Yeah, knowing that the paper that will be done in December, it is divided into 3 parts. Yeah, part 1 is theory, and this time they're testing 20 marks. 20 marks will come from the theory. Part 2 will be the specialization part. Yeah, specialization part of the core area, and the core area will be carrying 60 marks. Yeah, that is the core area, the financial management and financial reporting. And the part 3, we shall be having 3 questions on the specialization area. 3 questions on specialization area: a question from management accounting, a question from advanced, a question from taxation, and a question from auditing. Yeah, the 3 questions, each of them will be carrying 20 marks. You'll just be doing one. Yeah, part 1 is compulsory, you do one. Part 2 is compulsory, you do the 2 questions which will be compulsory. That means part 1 and part 2 carries 80 marks. Part 3, you do only one question, which is optional. Yeah, one question among the 3. Among the 3, you select one, and it carries 20 marks. Therefore, the theory is key for the 20 marks that you can easily get. And part A is a multiple. Part A is for the multiple questions. Yeah, multiple answer questions, whereby you'll be tested on A, B, C, D, on how you know the data, how well you know the data analysis. And therefore, today, being part 1 of these 2-part series, we shall be covering the first part under the introduction to data analysis. And part 2 of this theory, we shall look at the big data. Yeah, big data analytics. So under the introduction to data analytics, you shall be looking at the summary of the chapter, the cross-industry standard process for data mining, that is the CRISP, the framework for data mining, then the big data. So this one will be under part 2, the big data and data analytics under part 2. Then the tools for data analysis still will be under part 2, and data visualization. Yeah, so today we shall only cover the first and the second, the CRISP and the framework for data analytics. Then the lesson 2, we cover the big data and data analytics, the tools and data visualization. And in lesson 3, we shall look at the multiple choice questions. At least we look at 2-3 sample questions that we shall work it out. Under the data analytics, the summary, it's a comprehensive guide to fundamental concepts and framework of data analytics. In this chapter, readers will learn, so this is just but the summary, where it is introducing the chapters and what we are expecting to learn under this particular chapter. So we shall introduce, and starting with the cross-industry standard process for data mining. Yeah, remember, when you talk about data mining, is how we are accessing our data or how we are extracting our data. Yeah, data mining, that particular process. Yeah, so remember, when you talk about the data mining, that is a process whereby we shall be sorting through large data. We sort large data in order to identify whether we have several patterns that you can identify, whether there is a relationship, and this relationship and pattern, we are looking at them so that they can help us be able to solve business problem. We shall see later about solving the business problem, but that's what we mean by data mining. So it's a framework. This framework is a widely used process model for data analytics that provides a structured approach for conducting data mining projects. Remember, data mining is saying the process of acquiring data or extracting meaningful data from big data, from a very wide range of data. Then we shall mine and extract the meaningful insights and patterns and relationship from that particular data. So the framework consists of 6 major phases, which are, so the first one, we do understand the business understanding. Yeah, this phase involves understanding the business problem, defining the project goals. So business problem is what we are dealing with. What is our problem that we need to solve? Understanding what are the goals, what are the core goals that we aim and strive to achieve in that particular business. And again, we shall determine the scope of data mining project. So it will cover to what extent this data that we need to analyze which particular area of the business, which area do we need to make the decision on. That's why we are understanding our business, because before even we gather data, we need first to understand the business, and we need the objective is to identify the key business questions that needs to be answered through data mining projects. So the data that we need to analyze, the data that we need to extract, it will be used to answer which questions. And that's why the key thing, the first phase, we need to understand the business, understand it in all hemisphere, understand it from all points. Which problems do we need to solve, which key decisions do we need to make? And that's why first we do understand the business. After understanding the business, the second we understand the data. In this phase, data is collected and assessed to understand its quality, completeness, and relevance to the business problem. This includes data processing, data exploration, and data visualization. So here we are understanding the data. What are the qualities of the data that we need? After already we have understood the business, now we know the kind of data that we need. So this data that we need now to understand it. What are the characteristics of this particular data? Is the data complete? Is it relevant to business problem? And how shall we be able to process that particular data and be able even to visualize that particular data? And that's why it is key to understand the business, understanding the data. Then after we have understood the data, the quality, whether it is complete, and the relevance, we shall now prepare the data. And under data preparation, in this phase, data is transformed and cleaned to prepare it for modeling. So under data preparation, so we are transforming and cleaning. Transformation is to make sure it is either in standard form. We are cleaning it to remove errors. If there is any errors, any duplication, any incompleteness, that one we shall be dealing it under data cleansing. These include feature selection, data sampling, and data integration. That is under data preparation. So we have understood our data, we prepare our data, cleaning it, making the data to be complete, we transform it. Transformation, making it, or making the data, or making sure the data is in the required form. Required form, whether it is structured form. That's where we are transforming the data under data preparation. After already we have prepared our data, now we shall be able to model it. Modeling. In this phase, various models are developed using data mining technique, such as classification, clustering. You can use the regression, which is widely used, association rule mining. The best model is selected based on its performance and suitability to the business problem. So already we have defined and we have understood our business. We have understood the data. Now we have prepared our data. The next, we model the data. That data that we have prepared, we shall fix it in a model. Remember, the model is a system that will be able to be used to analyze the data, like the regression equation. When we put the values of x, you will be able to get the values of y. You'll be able to get the value of y. So that is a part of modeling. And we are selecting first. Before we select the best, we are selecting various types of model, and trying this particular data on this model, so that the best model that will suitably fix our problem or solve our problem, that is a model that we shall select under the modeling stage. After the modeling stage, now we shall evaluate. In this phase, the selected model is evaluated. So the selection or the evaluation stage is for the model. We have selected the best under the modeling stage, so that best model we shall evaluate. We shall evaluate and validate it using a separate data set. So we shall validate it. When you talk about validating the system, we're making sure the system is working as we had entrusted it to work, or already we had planned the way the system, because already we had seen the outcome. And the validation is where we know 1 + 1 is 2. When we fix it through the system, we need it to give us a 2. If it is giving us a 3, then the system is not working as it's supposed to be working. And that's why we are putting a separate data set that already is prepared in advance, and this data set already we know the outcome. Where we talk about the garbage in, garbage out, already we know the garbage out. So when we put this garbage in, we are expecting the garbage out to be of certain type. So it's it gives us the correct, then it will pass the test. This particular model that we are modeling, it will pass the. Then the other phase is where we do after this, and we're saying the performance of the model. The performance of the model is measured using various metrics such as accuracy. Is it accurate? Garbage in, garbage out, accuracy. Then precision. Is it giving us exactly what we need? Precision is exact. Accuracy, which is exact. Recall and FI score. Recall and FI score. And Yeah, so we are saying we are looking at accuracy and precision and recall, and this one should be F1, not Fi. F1 score. Remember, F1 score is a combination. It combines the measures that is from precision and recall, and it finds the mean to give a single metric for performance. Yeah, it is a combination F1 score, combination of precision and recall, so that it can give us a single measure. Yeah, that is the harmonic mean between precision and recall, and still we are using it for evaluating our model. After we have evaluated our model and it has passed all the tests and the model now is good, it is accurate, precision, it is giving us exact what we need, then we shall deploy that particular model. We shall do the deployment. Under the deployment, in this phase, the selected model is deployed and integrated into the business process. So it will be deployed and integrated into the business process. This includes creating reports, developing dashboards, and deploying the model in a productive or production environment. So already we have selected the model and it is really working, so it will be integrated now to assist in solving the business problem. And this business problem, it will now be used to create reports, developing dashboards. These are visualization tools, and again it will be deployed in a production environment or a productive environment where it will be used on a daily basis. So those are the 6 phases of cross industry, of the cross industry standard process, the CRISP standard process. So we have said the first, we understand the business, we understand the data, we prepare the data, we model, we evaluate, and later on we do the deployment. We look at the data concepts. Data concepts are 3: the conceptual, the logical, and the physical data models. The 3 of them. We start with the conceptual, logical, and physical models are different levels of abstraction in data modeling that represents different aspects of data in its structure. So we look at the first one, the conceptual data. This is a basic for the non-technical users, the basic for non-technical users. A conceptual data model is a type of data model that represents the high-level concepts and relationship between data entities in a system or organization. It is a non-technical representation of data that is designed to be easily understood by business stakeholders and other non-technical users. The main purpose of conceptual data model is to provide a high level of view of data requirement for an organization or system. It identifies the key data entities and relationship between them without going into detail about how the data is stored or implemented. So for the conceptual, it doesn't go into detail over how the data is being stored or how the data is being implemented. It's just being used by the non-technical, and it is used by the non-technical in order to understand, easily to be understood by the business stakeholders and non-technical users. The main purpose of the model is to provide a high level view of data requirement. So which particular data do we require when we are dealing with the modeling of our system for an organization or system? Just the high level view of the data requirement of an organization or system. So it will identify the key entities and the relationship between them. The key entities within the organization, those are the ones that we are identifying. If it is the departments, if it is the major units that we are selling, major products, those ones can be the units and how they relate to one another, because relationship is key here. We are looking at how they are related to one another. So that is a conceptual. So conceptual data model are typically created during the requirement gathering phase of a project and are used to document the business rules and data requirement of an organization. They are also used as a communication tool between business stakeholders and technical teams to ensure that everyone has a common understanding of the data requirement. So that is a conceptual data model. Then the second one is a logical data model. So logical data model now moves from the generality of non-technical now goes to technicalities of it, because this one is for the database administrators that is used during the design phase. The logical data model is a type of data model that defines the specific data structure. Now here we are going into specificity, defining the specific data structure and relationship between data entities in a system or organization. It provides a more detailed view of the data requirement than a conceptual data model. So this one is providing a more detailed view, more detailed view of the data that we are having, data requirement, and it is used to guide the development of the physical database. So the logical will guide in the development of the physical database, and that's why we are going into the specific data structure, the way the data is structured, so that we can use that structure and the relationship to be able now to develop a physical database. So the main purpose of the logical data model is to define the data entities, attributes, relationship, and constraints in a way that is independent. So here we are defining the entities, we are defining the attributes, we are defining the relationship and constraints in a way that is independent of the specific technology used to implement the data. Specific technology used to implement the data, So the key is this, that we are talking about the entities, we are talking about the attributes, the relationships, and the constraints. So those are the key that we are talking here, and the way now they are related, and in a way that it is independent of the specific technology used to implement the database. It is a technology independent representation of the data that is designed to be easily understood by technical stakeholders such as developers and database administrators. So that is key. Here we are using the technical stakeholders, and these technical stakeholders, they are the developers and database administrators. These are the people that are using now the system, the people that are using the system, or the people that are developing this particular system. That's why we are calling it a high level now for the technical people. In a logical data model, data entities are defined in detail. Here now we are going into details, including their attributes, relationships, and cardinality. So remember, cardinality now is the number of entities that can be associated with each other. The model also includes constraints such as the business rules. So here again we are looking at the constraints, and these constraints is the business rules, data validation rules to make sure that the data is being used, or the data entry is correct and accurate, and the referential integrity constraints. So these are the elements that are being applied, or the elements that we are looking at again when we are developing, so that we make sure when we are developing this system, we have looked at the rules, we have looked at the validation rules, everything has been taken into consideration. And remember, all these are being taken into consideration to do what? To ensure that the data is accurate and consistent. So consistency of the data and accuracy of the data, that's why we are looking at the business rules and the validation rules, and again the referential integrity constraint, to make sure that the system that we are developing is of high integrity and it will give us accurate and consistent answers. One of the key benefits of logical data model is that it provides foundation for database results, database design. So it will give us the foundation where we are now designing the actual database, one that we are calling the physical database. And when you talk about the database, the simplest way to understand a database, understand the access, because access is normally database. That is all the database. When you talk about the relationship between tables, when you talk about the primary keys, when you talk about the foreign keys, that is under database or MS Access, which is a basic model that can be used to develop or create the databases. And that's why under the logical, it will give us a foundation of creating and designing the database, and these designs that is consistent with the requirement of the business. So by defining the data structure and relationship in a structured and standardized way, logical data model helps ensure that the data design is accurate, efficient, and maintainable. That is another thing that we are considering, that the data is accurate, it is efficient, and it is maintainable. We can easily maintain that particular data. So the third now is the physical data model. So remember, we have looked at the logical and we have looked at conceptual data, the logical, now the physical. A physical data model is a type of data model that defines the specific technology and storage requirement for implementing a database. It represents, so here we are looking at physical data model, type of data model that defines the specific technology and storage requirement for implementing the database. Those are the two key things under the physical. Now here now we have already created the database under the logical. Here now we need to implement this particular database, and we are looking at which particular technology shall we be able to use, how shall we be able to store our database, or where shall we be able to store our database, and what size do we need that will be able to accommodate our database. And that's why now for the physical we are looking at the specific technology and storage requirement for implementing a database. So database implementation happens under the physical data model. So it represents the physical implementation. Here we are looking at the physical implementation. Physical implementation of the data structure and relationship. It defined in the logical data model. So what we had defined in the logical model, what we came up as the designs, they are implemented under the physical now, and it is used by the database administrators and developers to create and maintain actual database. So here we are creating, and what we are talking about implementation, we are creating and we are maintaining the actual database. Under the logical we are looking at the physical designs, but here now is the actual database. The main purpose of the physical database data model is to specify the technical details of how the data will be stored, and that's why we are talking about the technology and the storage. That is what is covered under the physical data model, how the data will be stored, how it will be organized, and how it will be accessed through the storage. When we store it, how shall we be able to access that particular data? So it includes details such as data types, the indexes, the partitions, table spaces, and file layout used to store the data. So in physical data model, the data entities and relationship defined in the logical data model are mapped to specific database objects such as tables, columns, and indexes. The model also includes details about how database will be partitioned and distributed, and how data will be accessed and processed. One of the key benefits of the physical data model is that it provides a blueprint. It will provide a blueprint for the actual database implementation, ensuring that it is efficient, it is scalable, and maintainable. So it will give us that particular framework, our blueprint, a way, the way that we shall follow when we are creating and implementing the actual database, so that we can ensure the database that we have implemented, it is efficient, it is scalable, can increase the size, either decrease or increase the size of that particular database, and maintainable. Under maintainability or management, we talk about we can add, we can delete, we can modify under maintainability. So it becomes easy to add factors or to add elements there, to add elements there, so that you can either include or you can either reduce. Either include or you can either modify an element under that particular part that we are looking at, or when you are defining, or when you are already we have designed. So here is the implementation, and already the database is implemented and already it's there, already we have stored. That's why we are saying now whenever we are dealing with the implementation of the actual database, we are ensuring it is efficient, it is scalable, and it is maintainable. So by specifying the actual technical details of the database design, the physical data model helps ensure that database performs well and meets the needs of the organization, That is the physical data model. So those are the three, the conceptual, the logical, and the physical. And there's an example here on how the three model works. Just a small illustration on how the three model works, and we are using an example of a library. Assuming you have a library. So in this case now, under the conceptual, remember now here is a basic that we are coming up. The conceptual data model might include entities such as books. Remember here we are defining the entities and the relationship under the conceptual data model. So the entities such as books, authors, publishers, and borrowers. The relationship between these entities might include the author can write many books, or the borrower can borrow many books. So the conceptual data model does not define how the data will be organized or stored, how it will be organized or stored. So that is a conceptual data model. So here we are just looking at how they are related, the relationship between them, the entities and their relationship. Then under the logical now, logical model is more detailed than conceptual data model and specifies how the data will be organized and structured. So here is how the data will be organized and how it will be structured. It includes tables, columns and relationship between the tables. In our library example, the logical data model might include tables such as books. You may have a table, and that's why we are giving an example of the access. Whenever you are using the access, you may have tables to deal with books, a table for books, a table for authors, a table for publishers, and even a table for borrowers. The books table might have columns such as a book ID, a title, author ID, and even publisher's ID. The relationship between tables will be defined using the foreign keys. Remember, we have said we have primary and we have foreign. And remember, when you talk about the primary and foreign keys, they are normally to prevent duplication. You cannot duplicate. They normally lock the values so that they will avoid duplication. So books table might have foreign key like referencing the authors, table indicating which author wrote the book, etc. So that is an example under the way the logic now will tell us more on the detail. It's going to detail the tables and their content of those particular table. So the physical now is how we are storing and how we are accessing. Specify the physical implementation of the database. It includes information such as the file format. These books are stored under which particular format, the storage media, which storage media are we using to store our books, to store our information, and access methods. How shall we be able to access this particular information? So in our library example, the physical data model might specify that the database will be implemented using by my SQL. SQL is a server query, sequence query language. We shall look at that later. The sequence query language is a programming language. It's a programming language, and the books table will be stored in a specific file on the hard drive. So this one is just by the storage and how accessible, how we shall be able to access, our information. So those are the three, and a practical example on the three models, models. Then now we look at the stages in data life cycle. The stages in data life cycle, and they are the main. We have the major stages and the main. So this one now is a broad stages, where we shall first identify the data, identification of the data source. Then we shall deal with the modeling of the data, requirement, obtaining the data, recording the data, and using the data for making business decision. Using the data for making business decision. And the last one is removing the data. Those will be the major 6 stages that we shall be looking at. So the stages in data life cycle typically includes, first, we are identifying the data source. Where are we getting our data? What is the source of our data? So identifying data source is the first step, and from creation to disposal. In data life cycle, the step of identifying data source falls within data acquisition. We shall see the 6 stages or the 5 stages, which we are calling the phases. These are the phases, and these others are the stages that we have. Stages, they are 6, but the phases, they are 5. The phases of the life cycle, they are 5. Data acquisition phase, which is a phase where data is gathered and prepared for analysis. So we shall first start under identifying data sources, and we are saying it lies under the data acquisition phase. So these are phases, they are not stages. Stages, they are 6, phases, they are 5. So under phase 1, under the phases for data life cycle, data acquisition, this is a phase where data is gathered from various sources and prepared for analysis. So here we are gathering data from various sources, be it social media, be it from our applications that we are using, like QuickBooks, like Zoho, all those they are used, or even Pastel, Peachtree, all those are data collection tools. So we can collect tools and gather data, and they will be the source of our data. So the first step in this phase is identifying the relevant data source, which involves determining which source are most appropriate for data analysis. We can acquire data internally or externally, social media, all those from experts. That is data acquisition. Where do we get our data from? the source of data. That is the first thing, data acquisition. So after we have acquired, and remember this under the phases, after we have acquired our data, the next thing is we prepare the data. Remember the preparation phase that we had? We prepare our data. And when you talk about data preparation, where we are eliminating the duplicates, making sure the data is clean and accurate. Once the data source have been identified, the data is cleaned. Cleaning the data, and we shall look at the tools later under the second lesson, data cleaning tools. We shall clean the data, we shall transform, and we are saying we are transforming the data into standard form or structured form, that is accessible, or that is that the system or the model that we are developing will be able to be compatible with that particular model, and that's why we are transforming that particular data. Transformation involves transforming data from voice to text, transforming from Word to what, to PDF. All those will involve the data transformation. So we shall do transformation. We shall deal with formatting so that it can be analyzed effectively. So the main purpose for data preparation, we need to make sure the data that we are having is able to be analyzed effectively. Now this involves tasks like removing duplicates, that is under data cleaning, handling missing, still that one is under now fulfilling the data to be accurate, and normalizing data to a standard form, that is under the transformation. Now you normalize the data into a standard form. So we are removing the duplicate and you're handling the missing data. And remember, now this one is under what you're calling the cleaning, the transformation and formatting, and you're saying that the main reason is for effectively, for analyzing the data in an effective manner. So that is the second, data preparation. After now we have prepared the data, we shall analyze the data analysis. In this phase, data is analyzed to gain insights. The main reason we are analyzing the data is to gain insights and answer the questions posed by the project. Remember, the first thing we understood the business, and we are understanding the business in terms of the problems, in terms of the goals. So here now under data analysis, we are analyzing this particular data that already we have prepared, so that it will enable us to get insights that will enable us to answer the questions and make business decision. That is under data analysis. When you have analyzed the data, we shall do the visualization. Once analysis is complete, the results are typically presented in visual format. Seeing is believing under the visual format. When you see something, you will believe. You will believe about it. Seeing is believing, visual format, such as charts under visualization and graphs. We shall present it in charts and graphs. This makes it easier for stakeholders to understand and interpret the results. So it will be easier for them to understand and interpret the results. That's why we are visualizing it using the charts and using the graphs, so that the stakeholders can understand and interpret the results with ease. Easier for the stakeholders. You can easily see the comparison, you can easily see the deviation comparison, you can see the relationships, all those under the data visualization, and it makes it easier now when it comes to interpretation of that particular data. And the last one, after already we have visualized, we shall deal with storage and management. After the data is complete, the data is typically stored and managed to ensure ongoing usefulness and accessibility. The reason we are managing it, ensure that ongoing usefulness and accessibility is possible. This involves archiving the data. Later on we shall see that. You shall see that under the process of removing the data, being the last stage where we are removing the data, the last stage of the life cycle. And when we are removing the data, we can decide either to delete or to archive. Archiving it is not deleting, but you are putting it in archives, a place that we can easily access when need arises. And an example in our laptops and in our desktops, when you delete something and you are not deleting it permanently, that item or document goes to what we call the bin. The dustbin. And in this case, we call it, let me just get the right word for that. The recycle bin, not the dustbin. The recycle bin. And the recycle bin is where the data now will be stored after we have deleted it from our desktop or from document. Once you delete now data from the recycle bin, that data now, unless you use now other softwares to recover and retrieve that data, it is not easily retrieved. But once data is archived, you can easily restore it back from the archives. And the process of management still involves updating the data periodically and integrating it with other data source. That is under the process of management of data. We can easily integrate that data with other data sources. So those are the major 5 phases. So don't forget about the stages and the phases. The phases are 5, the stages are 6. And for the phases, the first phase we are saying is data acquisition. We acquire data from different sources, we prepare that data, we do the analysis, we visualize, and we store and manage that data. The 5 phases of the life cycle. Data life cycle has got 5 phases. Yeah, and you'll find out the 6 stages falls within the 5 phases. The 6 stages falls within the 5 phases. And like the stage 1 that you have looked at, identifying the data source, they are telling us it falls within the what? The data acquisition phase. Data acquisition phase, that is under the phase 1 of the life cycle. That is under identifying the data source. And you have seen we are identifying it from different sources. Then number 2, modeling data requirement. Remember, we have talked about coming up with models. Yeah, we have talked about coming up with models. So here we are modeling data requirement. Modeling data requirement is the second step of the data life cycle, which is a framework. Then in the data life cycle, the step of modeling data requirement falls within data preparation phase. Data preparation, this is the second phase for data preparation. So modeling falls under the data preparation phase, which is a phase where data is cleaned, transformed. This one we have looked at it. We are cleaning, transforming, and formatted so that it can be analyzed effectively. That is the second phase. So this is where modeling data requirement falls in. So the process of modeling data typically involves the following steps. The first one is defining the scope of the analysis. So we define the scope of our analysis. This involves determining the objectives of the analysis and specific questions that the analysis will seek to answer. What are the questions that we need to answer from this particular analysis? That's why we are defining the scope of the analysis. Then the second one, we identify the relative data fields, the relevant data fields that we need. Remember, now under modeling is where we are coming up now with the system. Yeah, the system, that's why we're talking about the modeling. We first need to know the scope. This system that we are developing, it will be able to be utilized in which particular area, the scope of the analysis. It will be required to analyze data to what extent. That's why now we need to define the relevant data field. Once the scope of the analysis has been defined, the next step is identify the relevant data fields that will be used in the analysis. This may involve reviewing the data sources first. What is the source of the data that we have identified under the acquisition phase, and determining which field is most relevant to our analysis. So we shall define which particular fields are relevant in our analysis so that they will be included whenever we are having now the model, we are modeling the data requirement. Then part C, we define the data relationship. After already we have identified the relevant data field, define the data relationship. Once the relevant data fields have been identified, the next step is to define the relationship between the data field. This may involve identifying the key variables that link the data field together. The key variables that link the data field together, and defining the rules for how the data field are related. So we shall be able to define those particular rules. So the relationship, because once you are preparing a database cannot be able to communicate. The tables cannot be able to communicate to each other if there is no relationship between the tables. So there must be an item that is causing that particular relationship, so that you can easily be able to communicate with that particular table and be able to extract data that we need, analyze the data from that particular different tables and different fields. So the communication is key, and that's why now here we are defining the data relationship, the relationship between different data fields. And after we have defined that, we develop the data models. Now we come up with a model. Once the data requirements have been defined, the next step is to develop the data model. This may involve using variety of tools and techniques such as the entity relationship diagram, the data flow diagram, and the data dictionaries. These are some of the methods that can be used when we are developing now the data model, making sure the model is up and running. So after number 2, now we have already modeled the data requirement. We know all that will be required and the model that is able to handle all that data requirement. The next will be obtaining the data. Now this is that step, and it falls in the data life cycle. The step of obtaining data falls within the data acquisition phase, still under data acquisition, which is phase 1, data acquisition phase, which is the phase where data is gathered and prepared for analysis. That is under phase 1, where we are gathering data and we are preparing it for analysis. The process of obtaining data typically involves the following steps. Selecting the data source, that is the first. This involves determining which sources of data will be used in the analysis. So we are determining which source of data will be used in our analysis, and this source of data can include the internal database, the external database, the data feeds, the data purchased from third parties. So those are the various, I had mentioned them, various sources where we can get our data, whether it is internal, whether it is external, or whether we are purchasing it from external data providers. So first, that is the first step under obtaining the data. We know where we are getting our data. The next, we extract. Already we know where we are getting the data and we have gotten the data, whether it is internally or externally. Now we do extract the data. We know not all the data will be useful to make the decision. We just need to extract the data. The fields that we fill, this one will assist us in making an analysis that will be useful to the organization. So we shall do the extraction of the data. This is where we are doing the mining now of the data, important data. Once the data sources have been selected, the next step is to extract the data. This may involve various data extraction tools and techniques to extract the data from the source system. We shall see later the tools that are used to do extraction of the data, but that is the second part, part B. After already we have extracted the data, we need to clean that data to be clean. Remove the errors and we transform the data. It's like the repetition that already we have looked. So here now we are cleaning and we transform the data. After the data have been extracted, it may need to be cleaned and transformed to prepare it for analysis. So you need to clean it and transform it. This may involve tasks, removing duplicate. This one I have said is under the cleaning. Handling missing, that is still under the transforming now, or still under the cleaning. Cleaning the data, making sure you don't have any data that is missing. Normalizing data now is under the transformation to a standard form. You're normalizing the data into a standard form, that is under the transforming the data to be in a standard form. Standard form is acceptable form that will be used in that particular model. If the model only models the numericals, there is no way you can use the numbers. If it can't accept numbers, we have to format it into numericals. Then after already we have cleaned and we have transformed, we store the data. Once the data has been extracted and cleaned, it needs to be stored in a format that is easily accessible for analysis. So here we are just storing it, waiting for it to be analyzed. This may involve storing the data in data warehouse, the data mart, and in other storage. So the storage, and we have said that we are storing it in a data warehouse. Remember, when you talk about the data warehouse is where different types of data will be stored. When you talk about the data mart, here is a specific data will be stored in a data mart, and you will find that the data mart is a subset of a data warehouse because this one is storing a specific data, but this one is all the general data. All the data is stored in a data warehouse or other storage system, so that now if you need to access specific data, it will be accessed through the data mart. So the next stage, number 4, is recording data. Stage number 4 is where we are recording the data, and you'll find that it's a 4th step in the data life cycle. And in the data life cycle, the step of recording data falls within the data acquisition phase. We talked about the data acquisition phase, and which is the phase where the data is gathered and prepared for analysis. So here it involves gathering the data and we are preparing the data for analysis. So here the process of recording data, typically we create the data records. It involves creating records for each piece of data that has been obtained. So we create record, and this record includes information such as the data source, where did we get the data, the date when the data was collected, the date which the date and the date the data was obtained, and any other relevant metadata. Metadata is an extension, any other information in connection with that particular data. That is the first step that we are dealing with, creating the data records. But we have created the records, we shall store the records. Once the data records have been created, they need to be stored in a format that is easily accessible for analysis. So we need to format that data and store it in a format that it will be easy for us to do the analysis. We shall store it in either database, in either spreadsheet, or in any other storage system. So then after we have stored the data, we shall managing. Remember, we said is where we are updating the data. After data records have been created and stored, they need to be managed to ensure that they are accurate, complete, and up to date. This may involve tasks such as verifying the data, updating the data records, and archiving old data under the managing of the data. So we are creating the data that we have stored. We are making sure that that data is accurate, it is complete, and it is up to date. And how do we make that, or how do we achieve accuracy, completeness, and the data is up to date? Is by verifying the data, so that we remove any errors, we remove any duplicates, then removing any missing, filling any missing data. That is to make sure the data is complete. Then we update the data records, that is making sure that the data is up to date. And if there is any old data that we are no longer using, we do the process of archiving that particular data. Then after managing the data, we shall secure the data records. Once the data records have been created and stored, they need to be secured to protect them from unauthorized access or theft. So we shall secure, because currently data is very expensive, and that's why you are finding there is a lot of hackers that are hacking data, having unauthorized access of data because of the way the data is. Currently the data, you can sell it for a lot of money when you access data that is meaningful. This involves using encryption, where we are using the password. Then you can use the access controls, controlling people who can be able to access our data that we have already stored, and other security measures to protect the data, encoding and encryption to protect the data. All in all, the process of recording data is a critical step in data lifecycle, as it ensures that the data is properly documented, stored, and secured for analysis. That is the process of data recording. Where we are ensuring that data is properly recorded, properly documented, it is stored, and again it is secured for analysis. The fifth one now is where we shall use the data for making business decision. Remember, all this process, the aim is to solve a business problem or to achieve a business objective, and that's why now, after already we have been able to gather and record and we have analyzed, then we shall be able to subject that data in making the decision. And these are now in data lifecycle. The step of using data for decision making falls within data analysis and utilization phase. Data analysis and utilization phase, which is the phase where the data is analyzed and used to drive business decision. So the process of using data for making business decision typically involves the following steps. The first one is data analysis. First we shall analyze the data. It involves analyzing the data to identify the patterns, the trends, and the insights. So you're analyzing that data so that you can identify the patterns, the trends, and the insights. This may involve using various analytical techniques such as statistical analysis and data visualization and machine learning. So when we use this one, now we can be able to analyze data to get the meaningful insights, to get the patterns and the trends, so that you can subject them to make our decision. Then after we have analyzed, the next we do the interpretation of the results. Once the data has been analyzed, the next step is to interpret the results. It involves determining what the data means and how it can be used to inform business decision. So you interpret the results. If the results of the regression model, you will interpret it and subject it now to decision making. After already you have interpreted, now assuming you are the party or you are the data analytics analyst, you will interpret and then you communicate the results to the users, the management. After the results have been interpreted, they need to be communicated to the decision maker. So here is the management. This may involve creating reports, presentation, or other material to effectively communicate the findings. So you'll create the reports, the presentation, the data visualization, the dashboards, so that now you can be able to communicate the results to the user. And users here, they are the management who are the decision makers. And after now you have communicated the results, the users now will make business decision. Finally, the insights gained from data analysis needs to be used to make decision. This may involve making strategic decision, operational decision, and or tactical decision based on the insights gained from the data. So this is the end, whereby now you are making the decision to improve your strategic decisions. Either it's the operational decision, we need to improve on our efficiency, cut on cost. Tactical decisions, the tactics that you are dealing with. Remember, all these decisions are being made by the top level management in the business, and they are using the data, the results of the data that we have analyzed, And the last stage, number 6, we remove the data. Now already we have made the decision and we have used the data to make this decision. Then we no longer now need this particular data, so we go to the process of removing the data. So removing data is the final step here, and it falls within the data disposal phase, under the phases of the data life cycle, which is the phase where data that is no longer needed is disposed or archived. So the process of removing data typically involves the following steps. The first one is identifying data to be removed. First we identify the data to be removed. This involves identifying data that is no longer needed or has exceeded its useful lifespan. So first you shall identify that data that we no longer need, the data that has exceeded its useful life. Remember, now this one will be determined by the policy of the organization. How long are we storing our data, or government policy, like for the VAT records where they're supposed to be stored for 7 years. This may include data that is outdated, redundant, or irrelevant. So that data that is irrelevant or is outdated or is redundant, it is the data that we shall be removed. It will be the data that we need to remove. Then we shall review the data removing policies, the policies that the organization have already set. Organization should have policies and guidelines in place for removal of data, and these policies should be reviewed and followed when removing the data. So remember, you cannot remove the data without authorization, proper authorization, and that's why now we are following the policy to make sure we are following and we are doing it the right way. We are removing the data that is supposed to be removed in line with the organization policy. Then after we have removed that data, now we have identified the data, we have reviewed the policy. So the next step will be now disposing the data. Once the data has been removed, data to be removed has been identified, it needs to be disposed in a secure and responsible manner. So we need to dispose that data in a secure and responsible manner. When you talk about secure and responsible manner, making sure the data is not accessible by unauthorized persons. Now we may think we have disposed, and maybe we have exposed that data to people that were not supposed to see or access that data. This may involve physically destroying the hard drives. So you said you shall destroy them physically, the hard drives or the storage media, and also we delete the files from the servers or database, and securely erasing the data from the storage devices. So that is a process where we are disposing our data in a secure and responsible manner. Then the opposite of disposing, we can decide to archive our data. If the data we need it for after some times, then you can archive. In some cases, data that is no longer needed for day-to-day operations may still need to be retained for legal or regulatory reasons. In this case, the data should be archived in a secure and easily retrievable manner. You can be able to do that. You can be able to secure and archive our data. So that you can easily retrieve that particular data. So that's the process of removing the data. From our system. And those are the 6 stages. Remember, the first one was identifying the data source. We have identified the data source. Then the second one, we have modeled. You should distinguish between the phases and the stages. There are 6. We identify the data source, we model the data requirement, then we obtain the data, then we record the data. The fourth, we use the data for decision making, then we do the removal of the data. For the faces, there are 5 of them. The faces, we have said faces are only 5, and for the faces, the first is we acquire the data. The faces, we acquire the data, then we prepare the data, we analyze the data, we visualize the data, and then we do data storage and management. We shall deal with data storage and management. So that is all for this lesson, so that in the second lesson we shall be covering the big data and data analytics. Big data and data analytics, this will be the part of the second lesson.